All right, slope-intercept form, y equals mx plus b. Point-slope form, y minus y1 equals m times x minus x1. And finally, standard form, ax plus by equals c. Each one of these have different purposes for different things, but one of the things that we're going to be talking a lot about today is how to write the equation of a specific situation given to us from a graph or from given information, okay? So if we look at this first one, we got to read through these questions kind of carefully, and I'm going to show you some different ways that you can get there. But you're going to have to do a little bit of work to get where you're going to need to be today. And then we're going to do a little bit of graphing along with it that we've been doing for the last couple of days. Write an equation of the line that passes through the point negative 1, 1, and is parallel to y equals 2x minus 3. So here's the first thing that I'm going to tell you today. Y equals 2x minus 3. Okay, it asks us to graph both lines. So the first thing that I'm going to do here is I'm going to graph this line on this coordinate plane. So if I graph 2x minus 3, where am I going to start at? Negative 3. So we're going to go down 3. We're going to make a point. And then my slope we think of as 2 over 1. So we're going to go up 2 over 1, up 2 over 1. And I'm going to do that as many times as I need to. Okay? Now I know I have a ton of points there. You don't necessarily need all of those points, but it does help me to draw a more exact line. And all the graphs that we're doing today are all going to be lines. There's no other types of graphs. If it doesn't make a line, we've done something wrong. Okay, so now we're going to make a new equation. That is parallel to the given equation and goes through the point negative 1, 1. Okay, if the slope of this original line is 2, what would be parallel to that? What did we talk about yesterday? If two lines are parallel, what do we know about their slopes? They're equal. They're exactly the same, right? And so what I'm going to warn you here is don't overthink it, right? Sometimes we think we have to do something to the slope. We don't have to do anything to the slope. This is my original slope, and my slope here is staying exactly the same. If it's parallel, don't do anything to it. Now, another thing I'm going to warn you about here, and so one thing that I like to do, we are not using this negative 3 at all. So I always put an X through it because some people see that negative 3 and they're going to be like, where do I use that negative 3 at? Well, you don't use it at all, okay? I don't want it to throw you off. So I just put an X through it saying we are not using that number at all, okay? The only thing that we need out of this equation is to graph it and what's the slope of it, okay? Now we're going to write an equation. And I'm going to show you two different ways to do this. For the first one, I'm going to show you y equals mx plus b. And then you can kind of decide which way you like better and then use that and then kind of stick with that method. Okay, so on this one, we know the slope and we know x and y. We know an ordered pair, right? Ordered pair is always x, y ordered pair. The only thing that I don't know in this equation is b. I have a y value, I have an m, I have an x, but I don't have b. I don't know where the y-intercept is. So I have to find that y-intercept. So I'm going to plug 1 in for y. I'm going to plug 2 in for m. I'm going to plug negative 1 in for x plus b. And I got to get b by itself. I want to solve for b. So to finish this out, to get b by itself, what would I have to do? Add 3. Okay? So b, or add 2, sorry. b equals 3. So my equation here is 2x plus 3. Y equals 2x plus 3. And it's asking us to graph this. I know what the slope is. I know what the y-intercept is. So now we're going to graph this just like we did the first one. Okay? Where are we going to start at? 3. And where is 3 going to go? Up on the y-axis. Always on the y-axis. So we're going to go up 3. My slope is still 2, right? 2 over 1. So we're going to go up 2 and over 1. We could go down 2 and left 1. Okay, and when I look at these two, they should be parallel, right? Are these two lines ever going to cross? No. See ya. Have a good weekend. So that tells me they're parallel, right? They both have the same slope. They're both parallel. Also, remember what it said at the beginning? That it should go through negative 1, 1. Look at it right there. Negative 1, 1. That's one of the points on this graph, right? So does it go through negative 1, 1? You bet. Okay, so we have a new equation that goes through, this point, just like it asked, and we have an equation for it, and we have a graph for it. Okay. Questions on that one? Okay, let's look at another one. Write an equation of the line that passes through 1, 5 and is parallel to y equals 3x minus 5. Once again, we're graphing both lines, okay? So let's graph the first one before we do anything else. Let's go down 5. Then we're going to go up 3 over 1. There's my graph. Been doing a lot of graphing the last couple of days, so we really got to make sure we understand how to graph. Okay, the slope of this one is 3, and once again, I don't need the y-intercept out of that equation. I always put an x through it once I've graphed it because I only need the slope from that equation. I can't stress that enough because I always get questions of where's that 5 being used at? It's not being used. We don't need it. It's not part of what we're trying to do. Only the slope is what we need. So the parallel slope here would be what? 3 over 1. Okay, it does not change. So it'd be 3. Hey, and then we're going to use a point, and the point that we are using is 1, 5. Okay, but on this one, instead of slope-intercept, I'm going to use point-slope. So this is just a different method, okay? And so what I want you to understand here is if you want to use slope-intercept every single time, you like the one that we did just a second ago, go for it. If you like point-slope, go for it, okay? Unless it says specifically you have to use this form, but here's what I will tell you is we're always going to end up in y equals mx plus b form. So that's why some people like slope-intercept better. I'll show you point-slope, and you can kind of decide which one you like better, okay? I wouldn't necessarily say one is necessarily easier than the other, just kind of a matter of preference more than anything. The one big difference here is we're going to label this ordered pair as x1, y1 when we do point-slope form, okay? Not just x and y, but x1, y1. Because when we put this in, I'm going to go ahead and rewrite the formula here. I am not going to put anything in for just the regular x and y. They're just going to stay x and y. So I'm going to go y minus y1. Well, y1 is really 5. So y minus 5 equals my slope, which is 3, times x minus 1. Hey, if it asked you to leave it in point-slope form, we would be done. This is the equation in point-slope form. But I think on big ideas, and I think on the test next week, slope-intercept form is the one we're going to typically finish in. Okay, and so if I want to finish it with y equals mx plus b, that means I got to get y all by itself. So if I wanted to get this equation and get y all by itself, what would I have to do first? Yeah, got to get rid of that 3, right? We're going to distribute that 3. Got to get rid of those parentheses. So this would be y minus 5 equals 3x minus 3. And then to finish it up, we're going to get y by itself. So we're going to add 5. And we get y equals 3x plus 2. And that would be our equation. Then we got to graph it. Okay, y equals 3x plus 2, where we're going to start at? Up 2. Okay, so we're going to go up 2, make a point. Our slope is 3, so we're going to go up 3 over 1. And there's where we are. Okay. All right, so as you look at these two, if we're going to leave it in slope-intercept form, for me, I probably would choose this method over the point-slope form, okay? The only reason I show you point-slope is because, hence the name, if we have a point and we have a slope, a lot of people think they have to use point-slope form, but not necessarily. Okay, it's just another way of getting there, more than one way to get things done. And so you get to choose kind of which one you would rather do in that scenario. Okay, these two problems are exactly the same thing, except for one thing. It's perpendicular. So you got to really read your questions carefully on big ideas today. Same thing as the test next week. Are we asking for parallel or are we asking for perpendicular? Hey there. You can just put it on my desk. Thank you. Okay, so once again, y equals 3x minus 5. Thanks. I'm going to go down 5. My slope is 3. We're going to make a line. Okay, it says to graph both lines. Okay, now, what we have to do is we're going to graph a line that is perpendicular to this line, and it's going to go through the point 1, 5. They give me that right here. If my original slope is 3, on the last two problems, we kept the slope exactly the same. We didn't have to do anything to it, right? But on perpendicular, what did we say we had to do yesterday? There's a little saying that we used. Flip the switch, right? Take this slope, which is 3, flip it over, and switch the sign. So if my original one is positive, this one would be negative. And you could say negative 3 over 1, or sorry, negative, I didn't flip it, negative 1 over 3. If the first one's positive, this one has to be negative, and vice versa. Okay? One's positive, one's negative, and it has to be flipped. And then we're going to put it into our equation. Okay? And here's where it gets a little bit tricky. Mainly because as we graph this one, you can use whatever method you want. Okay? I'm going to use y equals mx plus b because that's typically the format that we're going to use. If you want to use point slope form, then I'm okay with that. Okay? It's just another way of getting there. This is x, this is y. Y is 5. M is negative 1/3 times 1 plus b. We don't know what b is. We got to find out b. B is what we're looking for. If I take negative 1/3 times 1, it still is negative 1/3. How do I get b by itself now? Add 1/3, okay? And so, oh my gosh, we're going to get a b value that's a fraction, okay? End of the world, right? So I would just leave it as 5 1/3. If you want to change it to an improper fraction, you can, but that would be the best way to leave it probably here. So my equation here is going to be negative 1/3 x plus 5 1/3. We didn't give you a very good piece of graph paper here to graph this because it only goes up to 4.
It looks like it's upside down.
It might be. So we got to go up. Here's 5. So 5 1/3 is going to be just a little bit above 5, right? And so you're just going to kind of estimate about where it would be. Because we went 1, 2, 3, 4, 5, and then just a little bit more past that. 8. And then when I do my slope, I'm just going to go down 1 over 1, 2, 3. And I could do that again if I wanted to. And then I'm going to connect those together. Okay, and what should happen when we look at this, and we can't really measure it to verify this, but at least it should look like it's perpendicular, which means it should be doing what? Intersecting, and not only intersecting, but what should it be forming? 90 degree angle. Okay, and so does this at least look like it forms a 90 degree angle? Yeah, okay, and so we can't necessarily use I guess you could if you really wanted to, but we're not going to use a protractor to verify that it's really 90 degrees. But it should at least look like they make a right angle. Okay, this one a little bit tricky because we don't have in slope-intercept form. If it's in slope-intercept form, life is good. This one is not in slope-intercept form as it sits right now. So what am I going to have to do to get it into slope-intercept form? Subtract 2x. So this would be y equals negative 2x plus 2. Okay? I can't just look at this equation as it sits right now and say, that's my slope. Okay? I got to solve it for y. I got to get y by itself. Once y is by itself, what would be the slope of my original equation? It's negative 2, and this is my y-intercept. Okay, so we're going to go up 2, and then we're going to go down 2 over 1. There's my slope, or there's my graph. Okay, same instructions as the last one. Perpendicular goes through the point 2, 3. So if my original slope is negative 2, what would my perpendicular slope end up being? 1 over 2. Okay? Because this is 2 over 1, so this would become 1 over 2. Remember, we are not using this b value right here. So just cross it out. Once we've used it to graph, we don't need it again. So I'm going to graph a new line and write a new equation. Okay, I'm not going to do point slope again unless you guys want to do point slope or you want to do slope intercept. Okay, is there anybody that just loves point slope form? Anybody feel like they have to use point slope? And if you do, that's okay. Okay, and I won't have one problem with that one bit. I just wanted you to at least see it. so you can make that decision on what you want. I'm probably going to stick with slope-intercept most of the time when I do stuff. So we're going to go 3 equals 1/2 times 2 plus b. Bless you. 1/2 times 2 is 1. Subtract 1 from both sides. B would be 2. Bless you. So we get y equals 1/2 x plus 2. That's my new equation. Okay, they have the same y-intercept, which is kind of weird. That doesn't happen very often. Okay, but that is basically your intersection point here. So don't freak out if they both have the same y-intercept. But instead of going and doing the other slope now, I'm going to go up 1 over 2. Or I could go down 1 and left 2. And when I connect those two, it should at least look like they form a 90-degree angle. If they don't form a 90-degree angle, or if they don't look like they form a 90-degree angle, either I have the wrong equation or I graphed it wrong. Okay? Because we said they're perpendicular, they have to form a 90-degree angle. Okay? And I'm not saying we necessarily have anything that we can do to verify it, but if it doesn't look like it's 90, you need to probably go back and look at your graphs and make sure you graphed it correctly. Okay, I think you're going to see some problems today that are going to ask you, and I'm just going to add this real quick and then we'll talk about this last question. Parallel, perpendicular, or neither. Okay, if I were to give you these two equations, okay, this slope here is going to reduce to be negative 1/2, right? When I look at these two slopes, are these two slopes the same? Definitely not, right? Are they perpendicular to one another? No. I would have to flip the switch, right? So like for this one here, I would have to flip it over and I would have to switch my sign. Not even close, okay? So they're not parallel, they're not perpendicular, so what we would say here is these are neither one. So when you identify it, you could identify it with one of those three things. Are they parallel, are they perpendicular, or are they neither? I think you see some like that today, but I can't remember for sure if I'm thinking today or some other time. But let's look at this last one. A vertical line and a horizontal line. If I were to graph a vertical line or a line of x equals 4, we've talked about that the last couple of days. This is the line x equals 4. X equals 4 is always a vertical line. Y equals 2 will always be a horizontal line. And what do we know about a vertical line and a horizontal line? They always have to be what? Perpendicular, right? They're always going to form a right angle, okay? So a vertical line and a horizontal line always form a 90-degree angle. Okay? So if I have a vertical and a horizontal line, they will always be perpendicular. These two would make a right angle right here. Okay. Assignment should be up.